Hey, this is Mrs. Weethy, and we are now ready to do Lesson 3 in Unit Stoichiometry on mole-mole stoichiometry. So our learning goal in this lesson is to determine the moles of one substance in a chemical reaction when given the moles of another substance. So let's get rolling. Alright, right now we have two conversion factors that we are going to use in stoichiometry, and we're going to add more on as we continue our study. So the two that we know are, the first is the mole ratio, which is between two substances, substance B, which we're going to call the unknown, and substance A, which is the given. And it's always set up with unknown on the top and the given on the bottom. Where do these moles come from? This is what is derived from the coefficients in your balanced equation. Make sure you get that written down. Derived from the coefficients in your balanced equation. The second is the formula mass. Now the formula mass is for one substance, and the unit for the formula mass is grams over 1 mole. So both of these are going to serve as conversion factors in stoichiometry problems. Now, a general equation or a general plan for stoichiometry problems, we're going to use substance A as our given, as I said before, and substance B as the unknown. So in the plan, we're going to start with the mass of A. So mass is in grams. We can convert the mass of A to the moles of A, and the conversion factor will be the formula mass of substance A. You're going to use the conversion factor in this format, 1 mole over the number of grams. The beauty of the plan is that the arrow is pointing to the unit that will be on the top part of your conversion factor. Now, once you have the moles of A, we can convert the moles of A to the moles of B. So now we're switching from one substance to another substance. The conversion factor at this point is that mole ratio, set up as moles of B on top, moles of A on the bottom. You get those moles from the coefficients in your balanced equation. Now we can take moles of B and we can convert that to moles of A, to the mass of B. So moles of B convert to the mass of B. The conversion factor is the formula mass of substance B, set up as grams over 1 mole. So since you're going to the mass, you want grams on top, you want the moles on the bottom. Now the nice thing about this plan is that you can start and stop anywhere in this plan. If you're given mass of A, you're going to start here. If you're asked to find the moles of B, you're going to stop here. If you're given the moles of A, we start here. If we're asked to find the mass of B, we stop here. So you have to look at what you're given and what you're unknown to figure out where you're going to start and where you're going to stop in this general plan. Alright, so let's take a look at a sample problem. We have how many moles of carbon dioxide are produced when 10.0 moles of propane are burned in excess oxygen in a gas grill. So what do we know? First, the given. Alright, if we take a look at our problem, our given is 10.0 moles of propane. We're going to put that into our given. And then our unknown, we're asked to find the moles of carbon dioxide. How many moles of carbon dioxide? So moles of carbon dioxide. Second, we want to write a plan. Alright, in our plan, very simply, we're going to start with moles of propane, and the only thing that we can do is to convert to the moles of carbon dioxide. Alright, so one step, moles of one substance to moles of a second substance. Third, we need a balanced equation, and this would be our balanced equation. So we have 1 mole of propane reacting with 5 moles of oxygen to give us 3 moles of carbon dioxide and 4 moles of water. So it's a straight up hydrocarbon combustion. Next, we need to solve the problem. So we're given moles of one substance, we're asked to find moles of another substance, so we're looking at this part of our general plan. So the only conversion factor we need is the mole ratio, which comes from coefficients in our balanced equation. All right, start with your given 10.0 moles of propane. You're going to multiply by the mole ratio. Unknown is going to be on the top, so 3 moles of carbon dioxide over the 1 mole of the propane. Divide out your common units, moles of propane, and then round to the correct number, sig figs, which is 30.0 moles of carbon dioxide. All right, let's take a look at another problem. When dinitrogen pentaoxide is heated, it decomposes according to this balanced equation. The first part of the problem, we want to know how many moles of nitrogen dioxide can be produced from 4.3 moles of dinitrogen pentaoxide. We already have our balanced equation. All right, and so our given, and we're just going to write the given underneath the substance in the balanced equation. So we have 4.3 moles of the dinitrogen pentaoxide. Our unknown is the moles of nitrogen dioxide. All right, our plan. We want to go from moles of dinitrogen pentaoxide to moles of nitrogen dioxide. So again, it's just a one-step mole to mole ratio. Solve the problem. Start with your given 4.3 moles of dinitrogen pentaoxide. Multiply by your conversion factor with the unknown unit on the top. So from our balanced equation, you have 4 moles of dinitrogen or nitrogen dioxide over 2 moles of the dinitrogen pentaoxide. Divide out your common unit, do the math, round to the correct number, sig figs, and your answer is 8.6 moles of nitrogen dioxide. Let's do another using the same equation. This time we want to know how many moles of oxygen can be produced from the same amount of dinitrogen pentaoxide. Our given, 4.3 moles of dinitrogen pentaoxide. Our unknown, moles of oxygen. Our plan, moles of dinitrogen pentaoxide to moles of oxygen. And solve the problem, starting with the given. 4.3 moles of dinitrogen pentaoxide, multiply by your mole ratio. This time oxygen is on the top because that's our unknown, and we have 1 mole of oxygen over 2 moles of the dinitrogen pentaoxide are given. Divide out the common unit, do the math, round to the correct number, sig figs, and you get 2.2 moles of oxygen. And that completes lesson 3. Goodbye for now.